You guys needed that. That's too bad. Differentiate. Bye-bye. Differentiate left-hand side. Diff. Okay, here we go. 2n. 1 minus x. 2n minus 1 times derivative of 1 minus x is negative 1. Didn't you guys at first mention, Stefan, I think it was you, you said there's no 2n choose 0. I don't know if it was you or it wasn't, but it doesn't. You said there was no 2n choose 0. That should be already give you the answer. I told you guys this last week. I said if it's not, there's only two options. Or the week before, whatever it was. Option 1, it's either differentiated because your constant, if it disappears, it's differentiated. Option 2, it's disappeared to the left-hand side. So it doesn't always have to be derivatives. This is a 1. If 1 was subtracted, I could have also, I guess it looks like it's disappeared, but it would have disappeared to the other side. But you can see it's nowhere here. So that, to me, that would have been already a derivative question. Differentiate the green bit. The green bit becomes negative 2n, choose 1, plus 2, 2n, choose 2, x, because x squared is obviously positive. Next one. Plus 3, 2n, choose 3, but then you're going to get negative x to the power of 2 times by negative 1. Why is it times by negative 1? Because what happens when you differentiate negative x cubed? Negative the inside. And so on. All the way to the end. 2n, choose 2n. Bring the 2n down. Negative x. 2n minus 1 times negative 1 times 2n, choose 2n. Oh, that's messy. Oh, yeah. Differentiate this. Again, bring the 2n down. Negative x, 2n minus 1 times negative 1 times 2n, choose 2n. And I am literally 1 or 2 lines away. Yeah, at this stage, you pause for a second. You're like, well, I can see I've got my 2s, 3s, 4s, whatever. You now know that x equals to 1. So let x equal to 1. What happens? You get 2n. 1 take away 1 is 0, which is just 0. That's just all 0. Equals, let x equal to 1 here. You get negative 2n, choose 1, plus 2, 2n, choose 2, minus 3, 2n, choose 3, plus 4, 2n, choose 4. I think you should all know the answer. Plus 2n, 2n, choose 2n, and then again, just look at what I have. Can you see all the negatives are going to go to the left-hand side with the 0, all the positives are going to stay on the right-hand side, and you're done. So this becomes 0, and then all the negatives, let me highlight them. That one, pretty much all your odds. All your odds will go to the left, and that's it. You just rewrite the question. There's nothing for me to say there. Maybe you draw that. Your evens stay on the right hand side and you're done. 2n, choose 1. See, Rosemary, I told you we've done it before. All the questions that we have done are the only questions you can get. Only. So that's the good news. The bad news is you've got to learn to think like that. Two and choose 2 plus. So one of the questions we've done will be in your exam. It won't be a different one. That's what I'm trying to say. So if you want, you can really memorize the 10 questions and that's it, or you just learn it properly and you'll be able to adapt it to any question. Okay, that's binomial done. Let's do inverse. And if you're having problems with that, I highly recommend going back over the videos. Believe me, by the time you go back and watch those videos, you will actually say, I really get this. Binomial needs, I think, 3 visits. So 3 revisits. You've got to really go over it 3 times before you say, yes. 3. It's not like other topics where you're just like, yeah, cool, makes sense. It's not really like that. It's not made to be like that. Okay. That's that is exactly the question you'll get. Either with the differentiation, without the derivatives, but similar style of thinking. All right, inverse functions. I really would like to do exams, but let me have a see. Like exam questions on inverse. But what do we have? Let's see, maybe year 11 extension 1. What's a book you guys probably don't use? You guys probably don't use this one. So we'll get inverse questions from this guy. Did anyone actually use Fitzpatrick at school? Yeah? So this one looks familiar? That's your textbook? Fair enough. A lot of mistakes, Fitzpatrick. Out of the 3, it's the only one that's got, like I would say, 70% mistakes. So just be careful. Yeah, it's huge. A lot, ridiculous amount of mistakes. Well, yeah, it's a new syllabus. But that's just how they've always been. I'm just very careless like that. Okay. All right, we're looking for graphing functions, trig identities, there we go, and then inverse functions. Is that it? Trig, and yeah, that's the D12. All right, so we're going page 72 all the way to 111. All right, let's get this out of the way. 72. Yes, please. Dun, 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 dun. Okay, we made it. Our formulas. Do I need to revise these formulas? They look weird, don't worry about them. You guys use A's and B's. So again, please don't be shy. If you guys want me to go through it, just say yes. But to expand sine, A plus B, it's sine A, cos B plus cos A, sine B. For cos, A and B, it's cos minus sine. And then for tan, it's tan A plus tan B on 1 minus tan A, tan B. Any questions? No? Anybody? Okay, then we'll look at questions you probably will get in your exam. So you won't get any of this stuff, you won't really get any of this, you won't get that, you won't get that. Yeah, you probably will get, 100%, you'll get question 10. So maybe just try that. The clue I can give you is when you're doing sine 75, use your angles that you like, 30 and 45. For sine, sine A cos B plus cos A sine B. And then 75, yeah, you use sine 30 plus 45. No. There is one. All right, sine 30, what does it become? Huh? Cos 45 should be 1 on root 2 plus cos 30 should give you root 3 on 2, and then sine 45 should be 1 on root 2. Then that simplifies to 1 on 2 root 2 plus root 3 on 2 root 2. Add them, common denominators, and then rationalize. Yep, should give you exactly root 6 when you rationalize. Root 2 plus root 6 on 4. Yep, looks good. So that one will be in your exam. Just be prepared for it. That's obviously the easier form of it. All right, anyone want me to repeat that? Okay. Question 12, let me just have a look. 195. 195. Can you guys tell me the numbers you would have chosen for 195? What are the angles that you're going to choose for 195? What are the angles you like? What's the first one that you like? Start with the first one. 30, 45. And then he goes 60. Then he goes 90. Then he goes up increments of?
45, 60, and 90.
Yeah, you can. So that means you can do 150 and 45. 150 plus 45. What I was saying is, this one goes up by 15s, then it goes up by increments of 30. Those are the angles you like. So obviously you're going to choose 150 and 45. Okay? Same thing if it was 105, you could have done 60 and 45. You could have done 150, take away 45. Blah, blah, blah. All right. Next one. Then you've got your double angle results, which you need to know them. If you haven't memorized them, do not sleep tonight until they're memorized. That was my mentality. So don't sleep until it's memorized. What are they? Hold on, let's go back up. Yeah. Cos 2 theta is cos squared minus sine squared. Sine 2 theta is 2 sine cos. Tan 2 theta is 2 tan on 1 minus tan squared. All right, very good. Let's do this question. What will you get here? The questions you guys will probably get will definitely be like a prove or simplify question. Let me just find a nice one. Let's do G and try H. Try G, try H. And I'll be right back. know?
Yeah. This kind of actually forgot me.
You've been saying it for the last week.
I swear I called it.
Ciao. Bye-bye. Are we going out yet? No? Just simplifying. Let's say G. Sine x, cos x, and what? Cos 2x. What do I think? Well, cos 2x is cos squared minus sine squared. Cos squared x minus sine squared x. I usually don't like using that one. I'll use one of the other ones, either 2 cos squared or 1 minus 2. So I'm going to change cos squared. Doesn't matter which one you did. It doesn't matter if it's a bit different to mine. 1 minus sine squared, minus sine squared. Obviously becomes 1 minus 2 sine squared. And then really just expanding that. What's that? Sine x, cos x, minus 2 sine squared x, sorry, sine cubed x, cos x. For those who changed it to cos squares, yours would have probably been cos cubed and so on. But that's fine, same answer. Can you do anything else to this? Not that I can see. I think that's it. Can you see anything else? I mean, you could have, if you really wanted to, there's a 2 sine x cos x in there. You could have done that, but I don't see that doing anything. So that's 4 marks. It's not a show question, to simplify. That's it. It looks like it's expanded and not simplified, but that's how these work. And 2 sine 2x cos 2x. Oh, that's easy. 2 sine x cos x is equal to sine 2x, right? That's your double angle formula for sine. Of course, if it's 2 sine 2x cos 2x, it becomes sine 4x, you mean. So the idea is, obviously, this is an x plus an x gives you a 2x. As long as there's a 2 in front, there's a 2 in front. 2x and 2x becomes 2x plus 2x, 4x. And that can work all the time. If I had 2 sine 8x cos 8x, the answer is sine 16x. Right? You're going to add them. A plus A, technically. All right. What else? Nah, you don't really get those ones. Half angle formula, T formula. You need to know your triangle. Let's try. Which one would you guys get? Yeah, I guess it'll be something like that. Try that one. I'll draw the triangle for you guys so you don't get stuck. There's your theta, 2t, 1 minus, 1 plus. And then from there you should be able to get tan and sec. And it's telling if that is equal to x, prove that x is this. Should work out. So what should we have? We should have now sec is 1 on cos. Right? 1 on cos minus tan equals x. But 1 on cos. Cos is adjacent over hypotenuse. So flip that, which is 1 plus and 1 minus. Minus tan, opposite over hypotenuse. Okay, you're at this stage. I think, if I haven't done that wrong. Is that right? 1 on cos, so you flip it, and then tan, opposite over... No, wait, opposite over hypotenuse. Opposite over adjacent. Is that what you're saying? 1 minus t squared. Yeah, that's better. Yeah, this is left-hand side technically, I guess. Oh, this is not even left-hand side. This is the result that was given, and then what you're trying to eventually get is there is the actual, yeah, you're just trying to, so essentially you're solving for x. But right now, x is this. You just got to simplify it to become that. I mean, sure, it's just algebra. Back to like term 1. Algebra, got nothing to do with trig. See? Got it out? So, common denominators, 1 plus t squared minus 2t, 1 minus t squared. I can straight away see that's a difference of 2 squares. And then once I see a difference of 2 squares, I look at my answer. I'm like, I need the top to be a perfect square. So I can cross it out, and I'm done. If you guys are doing it my way, then that's great. That's how you should have done it, without even thinking it's a perfect square. If not, yes, that's obviously t squared minus 2t plus 1, which is a difference of 2 squares of t minus 1. Hold on, if it's t minus 1, something's going wrong. No, t minus 1. But no, t minus 1, t minus 1 squared is the same as 1 minus t squared. So if you had used t minus 1, you would have got it wrong. You had to actually use 1 minus t squared. But these two are the same. Why? Because when you're squaring the numbers, it doesn't actually make a difference. 9 take away 1 is 8, 8 squared. 1 take away 9 is negative 8, negative 8 squared is still positive 8 squared. Okay, any questions? No? All right. And some more. Oh, yes. Yes. Again, I can safely say one of you will definitely, or one or more of you will definitely see that question. Very common exam question. Use the double angle formula. Do you know that? Yeah, that's. Sorry? So it's definitely tan theta on 2. Where theta is what? 45. Right? We agree with that? Tan theta on 2, where theta is 45. So theta equals to 45 degrees. Tan theta on 2, theta is 45. So then, essentially, what do you know for, that's T. Right? So that's T technically. T equals tan 45 on 2, which is tan 22.5 degrees. So essentially, you're trying to find T. Because if you can find T, then you can say that's tan 22.5. That's how it works. How do you find T? Well, that's when you jump into this and you use any of the three that you want. Pick one. Sine, cos, or tan? Sine. So you're going to do sine theta is equal to opposite over hypotenuse. And that's it. You know what theta is? It's 45 degrees. Plug it in and start solving. I would have chosen tan, because tan 45 is 1. But, you know, called that algebra units this time. There's a million different methods. Oh, no half, right? No, not our way, anyways. You guys got to get used to that. You're almost in year 12. You got to know this is a book called Fitzpatrick. They're going to do it one way. Maths in Focus, different teachers are going to do it a different way. Cambridge, going to be doing it a different way. Your school teachers are going to be doing it a different way. Me, I'm going to be doing it a different way. Exam teachers, if you look at their exams, at the back of their solutions, they're going to do it a different way. Yeah, you can't confuse yourself with different methods. So stick to one, and that's it. If it looks a bit weird, I should be your point of contact. You should be telling me, hey, what do we do with these ones again? And I'll tell you, this is what we did. Okay, so we should be up to what? Sine 45 equals 2t on 1 plus t squared. Sine 45, plug it into your calculator, do the square and square root thing, becomes 1 on root 2. Cross multiply, we end up with 1 plus t squared equals 2 root 2t. Bring everything to one side, because it's a quadratic. Okay, almost there. T equals minus b plus minus square root b squared minus 4 times a times c all over 2a. Next one, 2 root 2 plus, that becomes 8. 8 take away 4 is 4, so 2 on 2. Root 2 plus minus 1. Any questions at this stage? Does anyone remember what we have to do after this? It's not, because it's only you're only looking for tan 22.5 degrees. So you've got to plug that into your calculator, which is 0.414. Which one here gives you 0.414? I think it's root 2 minus 1. So that's the one you want. You got to choose one of them. Okay. Will be in your exams. That's all I can say. So again, go back, rewatch the video, just keep doing it again and again and again until your hand gets used to it. So that one will be in your exam. Now, just to make it clear, up here, you could have done sine, cos, or tan. The best one would have been tan, but doesn't matter. Again, any questions? Any of the lines? Any steps? Alright, what else? Prove. Nah, these are just all rubbish questions. Rubbish, rubbish, rubbish. Rubbish, rubbish. No, done. Then you get these ones. That's when we got to use these. This is the only formula I allow you guys to not memorize.
I just wrote the hot one, that was
Ah.
mine.
You don't need to memorize this. I'm okay with that. Let's see. Now we're just going to do some questions. Okay. What will be in your exam? What will be in your exam? In your exam, they'll probably look more like none of these. Yep, it won't really be any of these. I'm trying to find one. Sure, there has to be one. Yeah, maybe that basic one right there. But not even, no, it wouldn't be that one. It would be these ones. Alright, there we go. See how you can't use your double angle result? Because it says 2 sine 3 and then cos theta. So they're two different angles. Sine and cos multiplied, which one do you use? Obviously use the first one. That's A, that's B. Can you see you could have multiplied this by 2? I'm going to do that just to make it a bit easier. 2 sine becomes sine A plus B plus sine 3 minus theta. Sine 4 theta plus sine 2 theta. That's a question you'll likely get. And then just to make it a little bit trickier, where did the 2 go? Because the 2 is multiplied here, so I multiplied the 2 as well. Does that make sense? I don't need the half in there anymore, do I? So you can see this as halves, or obviously you can see this as 2. Right? It's up to you. Whichever one you find easier. They will say it again. Yeah, well, no, they can make this one hard. Remember, we've done a hard one where we did this multiplied by, let's say, cos 5 theta. The cos 5 theta, and then that would be multiplied this whole thing by cos 5 theta. Remember how we did that? One time? No? What? As if you would forget that question. Anyone at home remember that question? Nah. Yep. 100%. 120. When you guys see it, you'll remember it. Oh, that one. Oops. That one. Definitely was the lack of sleep, right?
So it wasn't 5 columns.
No. There you go. Let's try this. Wait, let me just copy the other formula in for you guys. Where is it? This one. How do I select? Forgot. That one. Copy. All right, good luck. Let's see how you guys go with this. Oh, you've got 3 of them. But I said you can't do 3. You can only do 2.
So you did not 11.
So, just to get you guys started, well, again, it's up to you. Do you want to do the sine and the cos, or do you want to do the causes together first? Sine and cos, all right, so you chose sine 4 theta with cos 2 theta. So which one's that? Looks like the first one again. So that becomes half, open big bracket, sine 4 plus 2 plus sine 4 minus 2. That's it. Any questions there? And then don't forget you're still going to have this 4 that you're going to multiply this whole thing by, and cos theta. So times 4 cos theta times by 4. That's how you do it. So you go do it one at a time. So then this line becomes half times 4, and then you're left with sine 6 cos theta plus sine 2 theta cos theta. Let's see if you can finish it off. No, not factorized, because it was already factorized technically, wasn't it? Look, it was cos. You guys are missing it, aren't you? Sine cos. Sine cos.
Yeah.
That's it. And then sine cos. You use it again. So it should become 2 times, open bracket, sine cos, half sine, so 6 plus 1 plus 6 minus 1 plus this one, half 2 plus theta, 2 minus. And you can probably see 2 times a half, and the half will cancel all out. You're left with the answer that you need, which is sine 7 plus sine 5 plus sine 3 plus sine theta. That will be what's in your exam. Yeah, it's just the formula just done twice. Okay. Yes. 2 times a half is 1, and then 2 times the other half is also 1. When you know the answer, you can just like kind of fudge it like that. It didn't bother me. Yeah, you kind of know the answer. You know what you're doing. You can work your way around it. You just have 2 times a half, whatever. Okay. No worries, mate. Like I keep saying, go back to your exams if you have to. Go to the videos. You'll be surprised how helpful they'll be. Back to this. Like I said, the textbook question is pretty useless. Overview of trig equations. Okay. Then you got to trig equations. Nothing fancy there, as long as you remember the add as many 360s as you like. All stations to central. So let's do 2 questions. Let's do this one. And we'll do solve that. And we'll also do, oops, we'll also do one that like this. Say that again. Hold on. Let's see. Oh, inverse. You make inverse to you make alpha the subject. Yes. Inverse sine. We're going to get to that soon. Solve. Please keep in mind when you're solving this, when you're inversing, you can't inverse a negative. Good luck. I'll leave that with you guys for a sec. The solution was 0 to 360. So we want from 0 to 2 pi. Solve for 0 theta to 360 or 2 pi. Whatever you guys are comfortable with by now, I don't mind. But if you're in your exam, if you said 2 pi, then you've got to obviously put it in terms of pi. What? Isn't this advanced? Because of the fact that it's a double angle, it's meant to be more extension, right? It's harder advanced. That's how it works. So
Just like the end of the paper.
it could be, it's going to be end of the paper. Because even like there's some band 5 students that can get it out. It's not really an end of the paper. It's just, you would say it's harder to unit, which is completely allowed. Okay, what do we have? 2 theta in hats equals inverse sine of a half. You didn't inverse it? What? Inverse sine a half. 30 degrees. Okay, then we do all stations to central. Where is sine negative? Tan and cos, so therefore your 2 theta is 180 plus, 360 minus. But what did I say? You've got to add 360s if you can, especially with 2 theta, because 2 theta means 2 revolutions. So add 360 or subtract. Subtract, we don't need to because it's from 0 to 360. Blah, 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 but you don't need to do more because it'll be a bit too much. The answers are and then if you need it in terms of radians, you're just going to divide by 180, and then, so technically, it's times pi on 180. What we've just done is divide 180 and put a pi. Divide 180, put a pi. Any questions there? Try the next one. Don't expand the sine, obviously. It looks tempting to expand. Don't expand it, just inverse it straight away. You just like you did with 2 theta. You can only add and subtract 360s at the beginning. Then you would deal with your, you mean subtract pi on 4. Yeah. You add it here. So what do we have? We should have theta plus 45 degrees or pi on 4. I'm going to use 45. I think it's just a bit easier to read. 45 degrees equals 45 degrees. And then you do all stations to central. Where is sine positive? Here and here. So you've got to add an extra angle, 135. Now, You can add 360s, or you can subtract. But because you know you're going to subtract this 45, you should add 360 here, because what's going to happen, that's going to get you 405, and do more if you wanted. But by the time you subtract 45, 45 take away 45 is 0, 135 take away 45 is 90, and then 405 take away 45 is 360. And those three are our solutions. So if you didn't add 360, you can see you've missed an answer. And then in terms of pi, something like that. Sounds good? All right, anyone have any questions again? Let's keep moving. Same thing. Oh, that looks fun. Let's try that. Solve that. Let me think. Solve. I'll prove. Solve. What's the only thing we know? Nah, because the angles you can't get rid of. If it was squared and stuff, yeah, but it's angles, you can't. The only formula I can think of would be this one here. Stop, not that one. This one here. Other than that, it would be our double angle results. So let me just have a look. Cos, this one here. Oh yeah, got it. Yep. Go. See how you need to know to use that? How to know to use that? Well, you know, you can't get cos 3x any other way, really. It's the only formula you have for these. So cos, you've got to use this one here. And then something should happen. Just take your time, do everything properly, write what you need down, and we'll do it together. So yeah, I agree with you. Rosemary, you said it's kind of endless. And you can see that like, formulas can overlap. It's a bit annoying. As an answer, 3x, you're solving it. Yeah, what are you doing? You're solving for x, right? So what you should have is, let me see the first line. Cos should be half bracket cos 2x plus x plus cos 2x minus equals cos 3x. And then we should have, I guess I would have multiplied by 2. So cos 3x plus cos x equals 2 cos 3x. Brought everything to one side. So that becomes what? 2 cos 3x minus cos 3x minus cos x equals 0. And now we're up to this line, which probably isn't any better. But at least now we've got everything to one side and we've only got 3 and 1. Again, any questions before I continue? Okay. What are we going to do at this stage? I'm thinking as well. Yeah, that's the only option really. I was trying to avoid it, but unfortunately I can't. Which means that we could have probably done a bit differently from the beginning anyways. Alright. Cos 3x, the only thing you can use is your compound angle results. There's no other way of getting rid of this guy. So, cos 2x plus x minus cos x, cos minus sine. So that becomes cos 2x cos x minus sine 2x cos x minus cos x equals 0. So cos minus sine. I believe trig will be your last one. That's the feeling I've got. So I feel like your last question will be trig based. Because that's the one you can make algebra really hard, like this. Continue. Cos 2x. I'm going to change that to cos squared. No, I'm going to change it to 2 cos squared x minus 1. That's just up to me. Minus sine 2x is 2 sine x cos squared x, right? Because that's 2 sine cos times cos is cos squared, minus cos x equals 0. Next line. That becomes 2 cos cubed x minus. Did I do a mistake somewhere? Oh. Thank you. Sine. So then that becomes 2 sine squared. That would have been annoying. Minus 2 sine squared x cos x minus cos x. Okay, where are we at? Now we've got minus cos minus cos. Minus 2 cos. And if I'm not wrong, we should be able to now factorize your cos x out. All right, we're almost there. I knew this was going to be hard. Well, I don't know if you can say this one's hard. I think I'll call this one long. There's hard questions and there's long questions. These are just long. All right, and factorize my cos x out and your 2, you might as well. You're left with cos squared minus sine squared minus 1 equals 0. So essentially we've got 2 cos x equals 0, finally. And we've got this cos squared minus sine squared minus 1 equals 0. Now there's two ways of doing this. You either change cos squared to 1 minus sine squared and then just go about it that way, or it's realizing this is your double angles. So whatever you wanted, again, it doesn't matter. And then solve. All right, I might just zoom it out. I think you guys should actually try that one more time, like from the top. So I really believe start from there, new page, and really do it again now. Yeah, 0 divided by 2. That's what I'm saying. You're going to finish it off. Start from the top again, I think. Start from the question. You don't have to do it exactly like me. You could have changed cos 3x from the top to cos 2x plus x. That probably would have been a bit easier, but I realized that from the beginning. I decided to go about it this way. It doesn't matter. But yeah. Just do it again yourself. Start on a new page. Don't do it somewhere you got to cram it in.
Not the truth. The answer is still going to be only between 0, 180 and 360. From 2 cos, so this one? Well, 2 minus 1. 2 cos 3x minus 1 cos 3x is cos 3x minus cos x. You get that?
Yeah.
Apparently we've got some answers for x. What did you get, Rosemary? 0, 0, 90, 180, 270, 315.
Would you do for
Isn't it 360?
cos 2x, would you do 360 and cos 360?
Oh, let me do that. Let me do it just to make sure.
360 plus 360 divided by 2.
It's 360.
360.
Yeah.
090.
All the way to 360, yeah? Yeah. Sure, Dave. I thought so, but let's double check it. X equals inverse cos of 0 is 90 and then 270. This one. Inverse cos of 1 is 0 and then you got 360, then you got 720 and you don't need more, it's going to be too big. So your answer here would be 0, 180, 360 as well as 90 and 270. Yep, those 5 are your answers. And then if you do go back and check, it should work. So just do that if you want to check it out. Cos, let's try 90. Cos 180 times cos 90 gives me 0. Cos 90 times 3 is 0. So it should work. All right. Anyone want me to double check any particular lines here? anything that you're confused about. Like I said, I will just do it again and again. Me at your age, I would have probably done this question, I don't know, 5, 6 times until I just could execute every line. Not that I understood it, I could actually write every line. And then from there, I started to get into the habit of, oh yeah, I've got to factorize here. Oh yeah, I've got to change cos squared here. I've got to change sine squared here. I've got to change cos 2x here. So, okay, any questions or should I move on? Or just hold on. All right, I don't hear anything, so I'm guessing move on. And we're up to the review, which is probably, let me have a look at the questions. Simplify, yep, nah, useless. Yep, good, yes, good, nah, good, nah, yes, very good, very good. So there's some here and there. I might, if you guys want it, I can give you that. Actually, let's just do it now. Let's do it, it's fine. I'll just paste it in. Oh, fantastic. Done. You guys can get that. There's that review, and then we've got inverse now. We understand that inverse functions are a reflection about y equals to x. For it to be an inverse function, it cannot fail the horizontal line test. So for example, a parabola would not have an inverse because it would fail the horizontal line test. It touches it twice. So if I restrict it, if I say it's just for this side here, all of a sudden it does work. This one here, it doesn't fail the horizontal line test, this will have an inverse. But that is also a point of inflection, horizontal point of inflection. Interesting one. Alright, so if you're reflecting, if you're still having problems reflecting, the only thing I can tell you to do is to draw your original function in like Texter and then bend your paper about this line. You got to try that at home, and then it should work out to flip and become this. So that's all I can really tell you. Unless you can actually see it, great. Okay, so the biggest thing you want to remember has to pass the horizontal line test. So for parabolas, like here, you're going to find the turning point, and then wherever the turning point is to the left or to the right is where you would have an inverse. All right, let's have a look at some questions, I think. Okay. Let's pick some questions from here. All right. How do we find, so for each of the following functions, find the inverse function and then state the domain and range of the inverse. How do we find the inverse? We just change x and y. So pretty much for A, what's our domain firstly? And range? What's your domain of the line? And what's your range? Change x and y, so your inverse, x equals 2y, take away 4,
x plus 4, and then divide by 2. Yep. And then, of course, what's your domain and range of your inverse? It is exactly the same, because the way it works is your domain becomes your range, and your range becomes your domain. So in this case, it's just all real x and all real y. All right, let's do the one that I think you guys can't do, unless you have practiced it. G. Haha, she already knows it. I mean, she's practiced it. Domain and range. We'll get to it. Maybe we can avoid it, but oh well. I mean, domain is, they gave it to you. What's the domain? Yeah, right. And then your range. If you think of your original graph, x plus 2, x plus 2. That's your original. It's got intercept at 0 and negative 2. So it looks something like this. And then of course, if it's saying x is greater than 0, it's only in this component. So what's your range? Y is greater than or equal to 0 as well. All right, that's fine. That's for the original. Just so we understand it. Now we want to find the inverse. So what do we have? We had y equals x squared plus 2x, so we get x equals y squared plus 2y. All right, what do we do now? Yeah, complete the square. Y plus, you have to complete the square. I guess you don't have to. Sorry, you could have subtracted the x and then the quadratic formula. It could still work. It's just that you got to know that c is your x, which is weird because usually your c's are like a constant. But anyways, y plus half it. Oops. Half of 2 is 1. Square it. Anyone have any issues with what I just did there? Complete the square. Half the 2, which is 1. Square it on the other side. There's still 1 plus x. Square root. And then minus 1. But of course, you can't get both answers. So you want everything above. So it's going to be minus 1 plus root 1 plus x. Why? Good question. Why? Because your domain is still going to be, for this one, x is greater than or equal to 0, opposite of this, and range is obviously going to be y is greater than or equal to 0. So if you chose the negative case, you're definitely guaranteed to always get a negative number. Whereas with a positive case, x being greater than or equal to 0, you could get at least 0. So yeah, it's that one there. You'll need to restrict it.
Yeah, I think not.
I was saying at the turning points. If they don't say nothing, it's at the turning point. This one here, it wasn't at the turning point. But that's because we only want this section here. Say it again? No, it's 0. No, turning point would be at negative 1. The turning point. It's where this they gave us the domain here. If they didn't give us the restriction, what I'm saying, oops, whatever, doesn't really matter. This is negative 2, this is 1. You'll do it at the turning point, whatever that is. Let's call it negative half. The reason why you'll do it at your turning point, because that's the point where this will be symmetrical, so therefore your horizontal line test won't fail. And it's either one. So that's why they'll give it. So if you said, you just tell us restrict, you have to say x is less than or equal to negative half, or x is greater or equal to negative half. Because both will give you an inverse. Yeah, it's not one or the other. All right, all good. Rub. Let's do another one. Let's try, I like all of these, like I like h and I like I. Let's try h first, log x plus 1. H. Y equals ln x plus 1. Again, what's my domain and what's my range? For those who have memorized this now, log of x plus 1, you go to the left 1. That means that's going to look like this. And you have, sorry? And at -1 is my asymptote. And then meant to cut at 0. Like that. Obviously, what's your domain now? What's your range? So for your inverse, straight away, what's your domain? What's your range? Remember the opposite way. Y is greater than equal to 1. Ugh. Of course. Just seeing if you like your weights there. X is greater than -1. Obviously, can't equal to your asymptote. And then y is greater than -1. All right, brilliant. But we still need to find my inverse function. So replace x for y. Solve for y. What are you going to do to both sides? Exponential both sides. Subtract 1. There it is. And we know that that's true. We know for an exponential, it's all real x. And we know the asymptotes move down 1, so y must be greater than -1. There you go. All good. Let's try one last one, and then I think we've got to move on. Let's try this one. No, that looks easy. Yeah, these are both easy. Because you're just going to go x equals root 5 minus y, and plus the 1, you're going to square it. All right, no, they're easy. I'm going to move on. What else? Show the following pairs have inverses by showing. Yeah, easy. It's given by nothing. Show you can't do that. Okay, inverse trig. So there's nothing for me to do with inverse trig. You have to memorize your graphs, and once you memorize your graphs, you should know your domain and range. So there it is, inverse sine. If you need to write that, copy that down. -pi to pi on 2, -1 to 1. Okay. Then we have the same thing for inverse cos. There it is. Copy that down. -1 to 1, 0 to pi. And we've got inverse tan. Inverse tan looks like that. -pi on 2 to pi on 2. Domain is all real x, but your range is obviously between -pi on 2 and pi on 2. That needs to be memorized. There's no way you can walk into your exam without having them memorized. The next thing you'll need to know is that inverse sine and inverse tan are odd functions, and inverse cos is not exactly even. It's got a pi in front of it, so like this. So inverse sine of -x is negative inverse sine x. Inverse tan -x is negative inverse tan x, and then inverse cos of -x is pi minus inverse cos x. So cos is not even. I mean, sorry, cos is even, and that's why it's doing that, but you need that formula. I don't think that would be in your formula sheet. See what I mean by look at your formula sheets? It's sometimes it's in there, sometimes not. Relying on nothing. Okay. Then we get to the questions. So let's first, before I do the show, let's look at the sketching, because they're the easier ones. Let's just do them. Okay, before we start, inverse sine looks like that. Pi on 2 to negative pi on 2. Inverse cos looks like this. 0 to pi, and obviously that's going to be pi on 2. And then inverse tan. Inverse tan looks like this. You can never reach 90 degrees. Really bad diagram, so you guys get the idea. Anyone remember how we did domain and range for this? Domain, we replace whatever's in with your angle in your domain. So for B, to inverse sine. So your domain is obviously -1 to 1. But because it's 3x, you replace it for 3x. For C, your domain will be -1, less than or equal to, replace the angle for the x. For D, your domain, replace the angle for the x. For tan, there is your domain's orbital x, so that doesn't matter. For G, your domain again is from -1 to 1, so replace. Okay, any questions there? And then obviously solve for x. Solve for x. -1 is -2, divided by 2 is -1. -1 is 0, divided by 2 is 0. If I haven't solved that incorrectly, I'm sure you guys are checking. Times by 2. Okay, pause there. Any questions? Nope. Those are our domains. Now ranges. What do we do for range? Yeah, you got to remember that it's not multiplied by 2, it's going to be monic. That's what we said, so it's going to be y on 2. So it'll look like this. Domain is -pi on 2, less than or equal to pi on 2, but it's not 2y or something, it's y on 2. And then you'll times everything by 2. Same thing here. Range is C, y on 3. So you've got to bring the 3 over. That's the logic. Times by 3, times by 3. D Can someone tell me what to do with D? -pi on 2. What did you say? Y on 3 is incorrect. Incorrect. It's not y on 3 plus 1. I'll give you a clue. It has to be monic. Close, but you're saying you're wrong. Nope.
Say it again. Y minus 1, you would have to minus the 1, then you would have to divide by 3. Remember, you want to make this monic. So y minus 1 on 3. That's how that works. You have to make inverse sine only. So you've got to bring the 1 over, then divide by 3. All right, then it's easy. Times by 3 and plus 1. G, obviously it's y on 2, but it's for an inverse cos. So your range is from 0 to pi for your normal one, but it says y on 2. I think we get it, times it by 2. You work out that? For G, have a look at it again. There it is. And I'm just saying it should be like that, y on 2, cross up 2, times it by 2. Easy. Then your shapes should not change. So the answer for B is right there. Except I'll just put negative a third and a third. Negative pi and pi. That's it. The answer for C is right there. I'll go negative 1 to 0 and negative 3 pi on 2 to 3 pi on 2. The answer for D is right there. Negative half to half and, well, whatever this number is, negative 3 pi on 2 plus 1 to 3 pi on 2 plus 1. But the shape is still the same. And G, negative 2 to 2, negative 2 to 2, 0 to pi. 0 to 2 pi, sorry, wasn't it? 0 to 2 pi, and then that would be pi, of course. So I actually found these very, very easy, obviously, and throughout the years, a lot of students actually found these very, very easy as well. So this shouldn't really be a difficult one. Just memorize easiest, I don't know what, 5 marks you can probably get. Sketching, find the domain and range. Okay, that's that part of inverse. Then we've got the other part, and I think that's the last bit of inverse, isn't it? Yep. The inverse is very short. You've got the actual, these ones here. Find. Now find, what do? Find the exact values of the following. Yeah, but you can probably get away with just plugging into your calculator. So with find ones, you can just plug it into your calculator. It's the show questions. Sorry? Yeah, but I'm saying you can just plug it into your calculator. For show questions, unless your teachers have told you to not do that, it's usually, yeah, because I know you can. Correct, which is show. What you can't put in your calculator is show. Like this one here, evaluate, plug it into your calculator. Find, plug it into your calculator. Arc sine just means inverse sine, by the way. But don't let that stress you out. It's just inverse. Now, evaluate. So we're going to do the show questions. Find, easy. Prove. We'll do it. Whatever it is, we'll try that. Sketch we just did. And I think we're looking good. Solve. Nah. Prove. All right, let's do it. Let's do these show ones here. Where are they? Let's pick some good ones. So this is the one that you're talking about, I think, before, where you said let alpha be something. That's this part of the topic. Okay. I'll start with the first one, just to recap. A. Show inverse tan of 4 minus inverse tan of 3 on 5 is equal to pi on 4. Okay, these ones you have to do let. Let alpha equal to inverse tan of 4. Let beta equal to inverse tan of 3 on 5. So essentially, what are you proving?
Alpha minus beta equals to pi on 4. Or we'll write IE, just so you know what you're trying to do. Okay, it's useless at this point in time, but what you can do is obviously tan both sides, right? So from here, you can get tan alpha equals to 4, and tan beta equals 3 on 5. From there, you draw a triangle. Alpha is there. Opposite over adjacent. 4 over 1. Opposite over adjacent. Okay. And then what? Any ideas? All right, any ideas?
Team both sides, it's like alpha minus beta equals team counter.
You've got to tan both sides. Otherwise, how are you going to bring in your tan alpha that you've just used in tan beta? So you're going to tan both sides. Good job, Elliot. Tan both sides, tan both sides. So essentially you're finding tan alpha minus beta is equal to tan 45, which is 1. Tan alpha is 4. So I don't know if we needed the triangle so much. I didn't think we did. Minus tan beta, which is 3 on 5 on 1 minus tan 4. Whoa, what am I doing? Go back. No, I know. Tan alpha, which is 4, minus tan beta, which is 3 on 5 on. Probably want to ignore the 1, don't we? I'm just going to tan on the left side. 4 equals 4 minus 3 on 5 over 1 plus 4 times 3 on 5. From the top of our heads, we can say that if that's going to equal to 1. Do you guys want to double check that? Plug it into your calculator. It should equal to 1. It must equal to 1. Yep. And then you're going to, so now you just proved that tan alpha minus beta is equal to 1. So then you're going to inverse both sides. You're going to get alpha minus beta equals to inverse tan of 1, which is pi on 4. Let's do that again. It might say this one here didn't require the triangles, but you can't assume that. You don't know which one will, which one won't. Say it again.
Do you have to write the last 3 lines?
Do I have to write the last 3 lines? Yes, because that's actually proving alpha minus beta is equal to pi on 4. In fact, you probably want to rewrite the sentence out at the end. So you want to probably write inverse tan of 4 minus inverse tan of 3 over 5 is equal to pi on 4. That should really be our last line. So inverse tan of 4 minus inverse tan 3 on 5 is equal to pi on 4. Let's try it again. Let's try, well, B. B is very easy. it just says inverse sine 3 on 5 plus inverse sine negative 3 on 5. Well, left-hand side equals inverse sine 3 on 5. And then what do we know about inverse negative? It becomes minus sine, which is, that was very easy. Any questions there? All right, let's try C. Inverse tan 5 on 12. Inverse cos 5 on 13. Inverse tan 5 on 12. Inverse cos 5 on 13 equals 90 degrees. Well, again, you let alpha equal to inverse tan 5 on 12, let beta equal to inverse cos 5 on 13. Tan alpha equals 5 on 12. Cos beta equals to 5 on 13. Any questions at this stage? No? And then we draw our triangle. There's your alpha, opposite over adjacent, 5 over 12. What happens if you find the hypotenuse? What's it going to be? Yeah, which becomes 13 eventually. And then look what happens with cos beta. It's saying it needs to be adjacent over hypotenuse. So that means beta is actually there. And what are you going to conclude with alpha plus beta? What must it equal to? Pi over 2. 90 degrees because angle sum of a triangle. And what is alpha equal to? Inverse tan 5 on 12. Beta is inverse cos 5 on 13. You're done. Inverse tan 5 on 12 plus inverse cos 5 on 13. That's probably the one you'll get, more than any of the other ones we've done. All right, maybe one for you guys to try. Let's try D. Yeah. Again, remember, inverse tan is an odd function.
Because I was getting
Yeah, the drill.
on the break.
And that was the second key part of the roll.
Right, did you get it out?
10 minutes ago.
10 minutes ago.
Yeah.
Good job.
Sorry, guys.
Inverse tan of a negative and a negative becomes a positive. So you get inverse cos 3 over 5 plus inverse tan 3 over 4 equals pi on 2. Alpha equals inverse cos. Beta equals inverse tan. And then again, cos alpha equals 3 on 5. Say it again. But the negative and negative makes a positive. Tan beta equals to 3 on 4. Draw your triangle. Alpha is there, adjacent, hypotenuse. Beta is opposite 3, adjacent 4. Therefore, alpha plus beta must equal to pi on 2. And you finish it off. You have to write everything I pretty much have written. There's one step that is different.
If you write plus, would you write original?
You can't get it out.
Huh?
Oh, it doesn't matter. You can write the original. That doesn't matter so much. But yeah. But yeah, full marks there. All good?
How many was that? 3?
How many marks is that? 3. Let me see. That would be 1 mark there, 1 mark there. Yeah, you probably should be 2 marks. But if they want to be really lenient, they could put 3 marks in. So, sorry?
Is this a proof?
Yeah.
Yeah.
Proof.
This one is solved.
Yeah, no, proving. So that's 1 mark there, 1 mark there, and then 1 mark for the final answer. Something like that. How are we going for time? Yeah. All right. I thought so. I thought we wouldn't have time for exams. By the time you guys wanted to do those topics. 3-minute exam question. Let's go. Quick. All right, do this one. Differentiate. You can't do that. Quick. Oh, there. Boom. The substitution t equals tan theta on 2. That's exactly what you guys just did. 2 marks. Come on. It's a piece of cake.
Yeah.
Use your triangle.
Which one do it?
A, just A. Maybe.